Assalamualaikum. My name is Batrisha binti Nazaruddin. My ID number is 2023805086. Today, I'm going to present about nutrients classification, macronutrients and micronutrients. Macronutrients. Macronutrients needed in large amounts. We have three types of macronutrients, which are carbohydrates, proteins, and fats. Carbohydrates, the main energy source. Composition, monomer, glucose is the basic unit. Chemical components, carbon, hydrogen, oxygen. Chemical formula, C6H12O6, bond, glycosidic bond. Proteins, for growth, repair, and body functions. Composition, monomer, amino acid are the basic unit. Chemical components, carbon, hydrogen, oxygen, nitrogen. Amino acid has 20 different amino acid, bond, peptide bond. Fats, provide energy and support cell function. Composition of lipid, monomer, glycerol and fatty acid are the basic unit. Chemical components, carbon, hydrogen, oxygen. Criteria, less soluble in water, bond, ester bond. Now I'm going to explain each of it. The first one is carbohydrates. Classification, we have simple and complex. Simple carbohydrates, we have monosaccharides and disaccharides. Monosaccharides, 1 sugar unit per molecule. Glucose, energy source, blood sugar. Fructose, sweetest, found in honey, fruits, and vegetables. Galactose, sugar in milk. Disaccharides, 2 sugar units per molecules. We have maltose, product of starch digestion, glucose plus glucose. Lactose, major sugar in milk and dairy product, glucose plus galactose. Sucrose, common table sugar, glucose plus fructose. Next, complex carbohydrates. We have oligosaccharides and polysaccharides. Oligosaccharides, 3 to 10 sugar units. Can't be digested in human stomach and small intestine, they pass undigested into large intestine. Bacteria digest them in large intestine, producing gas and other byproducts. Examples, raffinose and stachyose. Polysaccharides, more than 10 sugar units. We have starch, glycogen, and dietary fiber. Starch, grains, legumes, tubers, and plants from energy storage. Glycogen, storage form of carbs in human, in muscle cells. For storage, skeletal muscle, 60% used during activity, liver, 40%, glucose cells throughout the body. Dietary fiber, fruits, vegetables, legumes, and whole grains. Next, carbohydrates digestion. In mouth, starch to small polysaccharide maltose using amylase. In stomach, stomach acids inactivate salivary enzymes, stopping starch digestion. In small intestine, maltose to glucose plus glucose using maltase. Sucrose to fructose plus glucose using sucrase. Lactose to galactose plus glucose using lactase. Absorption of carbohydrates. Carbs are absorbed as monosaccharide in the small intestine. Absorbed monosaccharide enter capillaries, flow to liver, and converted to glucose. Absorbed glucose travel to liver or remain in bloodstream to maintain blood glucose level. The second one is proteins. In proteins, we have amino acid classification and protein classification. For amino acid classification, we have three. The first one, essential amino acid EAA, isoleucine, leucine, and valine. The second one, non-essential amino acid NEAA, adenine, arginine, and asparagine. The third one is conditionally essential amino acid EAA, arginine, glutamine, and tyrosine. For protein classification, we have two, complete protein and incomplete protein. Complete protein, high quality protein, contain adequate content of all EAA from animal sources such as meat, dairy, egg, fish. Incomplete protein, low quality protein, lack of one or more EAA from plant-based such as legumes, vegetables, grain. Functions of proteins: growth, maintenance, and repair body tissue, example given collagen. Regulate water balance and maintain proper acid-base balance, act as buffer. Transport function, enzymes, hormones, and antibodies. Energy, when carbs and fats are lacking, example given gluconeogenesis. Blood clotting fibrin, vision, eyes, retina, opsin. For nitrogen balance, we have negative nitrogen balance and positive nitrogen balance. Negative nitrogen balance, body losing protein and cause impairment through growth and development. Nitrogen in is less than nitrogen out. Positive nitrogen balance, body retain adequate protein to support the growth and development. Nitrogen in is more than nitrogen out. The last one is fats. Classes of lipid. Under lipids, we have phospholipid, triglycerides, and sterols. Phospholipid, lecithin. Triglycerides, 1 glycerol and 3 fatty acids. Sterols, cholesterol. Under 3 fatty acids, we have saturated fatty acids, monounsaturated fatty acids, polyunsaturated fatty acids, and trans fatty acids. Under polyunsaturated fatty acids, we have omega-3 fatty acids and omega-6 fatty acids. Next, anabolic steroid. Anabolic steroid is a synthetic fat-soluble hormone used by some athletes to increase muscle mass and muscle strength. A steroid which copy the action of hormones that stimulate muscle growth. Their use is illegal and can cause liver damage and other long-term health effects. Now we are going to figure out the differences between saturated fat, unsaturated fat, and trans fat. Saturated fat, no double bond, carbon is fully saturated with hydrogen. Unsaturated fat, H atom same site, carbon is not fully saturated with hydrogen. And the last one is trans fat, H atoms opposite. Unsaturated fat converted to saturated fat through hydrogenation. The molecular shape of the molecule changes. Lipid functions. The first one, protection. The second one, energy. The third one, fat-soluble vitamin. And the last one is insulation. For health implication, excessive. If we consume too much of fats, we can get heart disease, obesity, trans fat impact, cancer, and atherosclerosis. Now I'm going to explain about micronutrients. Micronutrients needed in small amounts. We have 3 types of micronutrients, which are vitamins, minerals, and water. Vitamins support metabolism and immunity. Examples, vitamin A and D. Minerals, important for bones, nerves, and muscles. Examples, calcium and iron. Water, essential for all bodily functions and hydration. The first one is vitamins. Introduction. Vitamins are organic, essential nutrients required in tiny amounts. Unlike macronutrients, they do not provide energy but assist in energy metabolism. There are 2 types of vitamins, which are fat-soluble vitamins and water-soluble vitamins. Fat-soluble vitamins, we have vitamin A and vitamin D. Vitamin A, the functions, vision, cell differentiation, immunity, reproduction, growth, and antioxidant. Sources, animal form, liver, cod liver oils, milk fat. Plant form, beta-carotene, carotenoids. Deficiencies, eyes, childhood blindness, night blindness. Skin, hyperkeratosis, rough and bumpy skin. Infection, retards growth and development and lead to bone deformities. Stored in liver, main, lungs, and kidney. For vitamin D, the functions, regulate blood calcium level, bone health, cell differentiation. Deficiencies, children, rickets, adults, osteomalacia, osteoporosis. Sources, sunlight and vitamin D synthesis. Dietary source, oily fish, egg yolk. Toxicity, hypercalcemia and loss of bone mass. Water-soluble vitamins. The B vitamins act primarily as coenzymes, helps catalyze the working metabolic pathways in cells. For vitamin B, we have thiamine, B1. The functions, energy yield reactions, nerve function. Sources, pork and wheat germ, whole grains products, and liver. Deficiencies, beriberi, Wernicke-Korsakoff syndrome. For vitamin C, the functions, collagen synthesis, antioxidant activity, iron absorption, synthesis of vital cell compounds, and immune function. Sources, potatoes, citrus fruits, and kiwi fruit. Deficiency, scurvy, bleeding gums, weakness. Toxicity, diarrhea and nausea. High doses. The next micronutrients is minerals. Introduction. Minerals is an inorganic compound found in nature, regulate metabolism, nerve function, and structural support. Lost through sweat, urine, and feces. Must be replaced regularly. There are 2 types, which are major minerals and trace minerals. Roles of minerals, we have 7 of it. The first one is cell metabolism, calcium, phosphorus, and magnesium. Next, growth and development, calcium, phosphorus, and zinc. Bone teeth mineralization, calcium, phosphorus, fluoride, and manganese. Antioxidant defense, selenium, copper, zinc, and manganese. Nerve impulse, sodium, potassium, calcium, and chloride. Blood clotting and formation, iron, copper, and calcium. And the last one is iron balance in cells, sodium, potassium, chloride. Now I'm going to explain about the types of minerals. We have major minerals and trace minerals. Major minerals needed in large amounts while trace minerals needed in small amounts. For major minerals, we have calcium. The functions: bone structure, nerve function, blood clotting, muscle contraction, cellular metabolism. Sources: dairy product, fish with small bone and dark green leafy vegetables. Issues: hypocalcemia and hypercalcemia. For trace minerals, we have iron. The functions: form hemoglobin, Krebs cycle, immune functions and brain functions. Sources: heme iron, only found in animal, meat, fish and chicken. Non-heme iron, found in both animal and plant. Deficiencies: anemia, poor growth, fatigue. And the last one, toxicity, cause poisoning, death in children, hemochromatosis. The last part of micronutrients is water. Introduction. Water makes up between 50 to 75% of your weight. Each water molecule consists of 2 hydrogen atoms bonded to 1 oxygen atom, H2O. We can survive much longer without food than H2O. Main functions of water: regulate body temperature, prevents from becoming dehydrated, control osmotic pressure in the body, maintaining a proper balance between water and electrolytes, medium for biochemical reactions. Distribution of water. We have ICF and ECF. ICF stands for intracellular fluid. Inside the cells, 55% 2/3 of total body water. ECF stands for extracellular fluid. Outside the cells, 45% of total body water, divided into compartments: intravascular fluid, interstitial fluid. Body composition, age and gender affect water percentage. Water balance. Our bodies maintain water balance by the mechanisms that control intake, thirst, and water excretion. When our body is low of water, kidney conserve H2O, reabsorb H2O, decreasing during volume and concentrating the urine. When our body is high of water, kidney form and excrete a large volume of diluted urine. Now, we already reached the last slide of my presentation. Hydration during exercise. During exercise, water loss through breathing and sweat. Effects of 1% body weight water loss: increased risk of injury. Other factors affecting water loss, especially during exercise: high altitude, low humidity, and high temperature. Signs of dehydration. We have 2 types, which are mild dehydration and severe dehydration. Mild dehydration: thirst, sudden weight loss, dry mouth, throat, and body leanings. Severe dehydration: pale skin, bluish lips and fingertips, confusion. Sport drink. Sport drink contain carbohydrate and electrolyte to help replenishing glycogen storage and electrolyte in the body to prevent dehydration. It is suitable for prolonged exercise. Benefits of sport drink are superior hydration, enhanced fluid consumption, carbohydrate replacement. The differences between sport drink and energy drink. Sport drink: flavored beverages that often contain carbohydrates, minerals, and electrolytes, and sometimes other vitamins and nutrients. While energy drink contains stimulants such as caffeine and guarana with varying amounts of sugar, protein, vitamins, sodium, and other minerals. That's all from me. Thank you for watching, and don't forget to enjoy your healthy life.